All right, so welcome to today's revision class. We'll be looking at trigonometry, and I've put together questions from past papers here on trigonometry. Okay, so we'll be revising trigonometry. So there are questions on the identities, um, and on solving trig equations, and then there's also some questions on graphing these trig functions. Okay, so that's what we're going to do. So if you have any questions, whatever we'll be doing, please feel free to ask. Okay, just unmute yourself and then you can ask your question so that you know. Okay, so we'll start with the trig identities, then we'll move to the solving of the equations, and then we'll go to the graphs. Okay, so that's how we're going to move in this class. So we start from the trig identities. Okay, so trig identities are one of the simplest things to do. Okay, the reason why they appear hard to some of you is because you do not know the basic identities. Okay, so there are basic identities, and then those basic identities, we're going to be using them to prove complex identities. Okay, so if you don't know the basic identities, then there's no way you'll be able to prove the complex identities. Okay, that's why it becomes a challenge. So you first have to know the basic trig identities. Okay, so I'll start by writing some of those basic trig identities here, and then we move like that to the questions now. So the first one that you have to know is that sine squared theta plus cos squared theta. This here is the same as 1. Okay, so whenever you see sine squared theta, cos squared theta is the same as 1. And be mindful here that this theta here can be represented by anything. Okay, because some of you, I know in your mind, you just be thinking it's always has to be theta. No, it can also be sine squared x plus cos squared x is equals to 1. So as long as what is here is the same, okay, then that identity is just going to be equals to 1. Then from this identity, we can get some other basic identities. Okay, for example, if I say the cos squared theta, take it to the other side, what am I going to have? I'm just going to have sine squared theta is equals to 1 minus cos squared theta. Okay, so meaning that wherever we see sine squared theta, we can also replace it with what? 1 minus cos squared theta. And then here I can also take the cos, the sine the other side, so that I have cos squared x is equals to 1 minus sine squared x. As I said, what is here does not matter as long as it's the same, okay? Even here, they can also be a y, even there y. It will still hold. The identity will still be true. Or they can be z, or they can be v. They can be any letter. Okay, but for most of the questions, there's going to be theta or an x there. Okay, so that's the first basic trig identity that you must know. The other one is for the tan. So tan theta, okay, is the same as, okay, tan theta is the same as sine theta over cos theta. This one you have to know. Okay, so you can replace tan theta with these. Okay, you can replace tan theta with this. And then what else here can we say? Okay, but this, again, this tan theta here, okay, it can also be represented as, okay, anyway, let me not write that one, can be confusing. So I'll go to the next one, which is the sec. So secant, the full name is secant like this, but when writing it, we're just going to be saying sec. So sec theta is the same as 1 over cos theta. This one has to be in your head, okay? And then the other one is what we call as the cosecant, which is just the reciprocal of the sine. So the cosecant, you write it as cos sec theta is equals to 1 over sine theta. Okay, in some books, they write this cosecant, okay, they write it as CSC theta, and then is equals to whatever I wrote there. So whenever you see CSC, okay, or you see cosecant, it's just the same thing. Okay, it's just the same thing. So you have to know that identity by heart. And then you also have to know that cot theta is the same as 1 over tan theta. Okay, but remember we said tan theta is this, right? So this one, I can also write it as 1 divided by, because this is just divided by tan theta, right? Okay, and this guy, we know what it is. So this will be equals to 1 divided by sine theta over cos theta. Okay, what do? We say 1 multiplied by, so this guy goes on top, this one comes down because I've changed the sign here from the divided by to the multiplication. So that is cos theta over sine theta. So this just gives me cos theta over what? Sine theta. So you can see that the cot, it's the same as 1 over tan. Okay, or you can simply write it as cos over sine. Okay, so those are some basic trigonometric functions, okay, that you need to know. Okay, the other one, the bonus one, is this one. Let me write it somewhere here. Okay, so the other one that you have to know is, maybe I should leave that one. I should erase one of these. So the other one that you have to know, the trig identity, is that 1 plus tan squared theta. This here is just the same as sec squared theta. Okay? And then 1 plus cot squared theta. This here is the same as cosec squared theta. Okay, so immediately you just know these identities that I've listed on the screen here. Then you will never have a problem in proving the identities. Okay, because every identity will just be coming back to this same thing that I've written here. Okay, every identity that you'll be given to just come back to this same thing that will be what I've written there. Okay, so you have to master these ones here. So you can master these, and then we'll be using them to prove whatever identity comes our way. Okay, and then there's also the issue of the double angle identities, but for those ones, uh, I'll state them if we find a question that is necessary with those questions there. Okay, so now that we've known the basic trig identities, okay, we can move on now and try to prove some of the identities. Okay, so the first one is this one here. Okay, please guys, if you don't understand, just unmute yourself and then you ask the question. Okay, so the first one says prove the trigonometric identity 1 over 1 plus sine theta plus 1 over 1 minus sine theta is equals to 2 sec squared theta. Okay, so now the secret in proving identities is that you always get the part that looks complicated, okay, and then you try to simplify it into the part that is looking simpler. So this guy here looks complicated. So we get this part and then we try to make it look like this. That's what we're going to do. Okay, so what can we do there? Okay, we're just going to add whatever we have here. So I'm going to say uh, the common denominator there will be what? We're just going to multiply the two denominators that we can see, right? These ones here. So it will be 1 plus sine theta multiplied by 1 minus sine theta. Okay, and then 1 plus sine theta into here, it will just be 1 minus sine theta. I multiply that by a 1 on top, I get 1 minus sine theta. Okay, plus 1 minus sine theta here cancels out with this. I get 1 plus sine theta. Multiplied by the 1 on top, I get 1 plus sine theta. So we're going to say this should be equals to the right hand side, because this is the right hand side here, and then this is my left hand side like that. Okay, so on top there, what do we see? We see that this minus sine theta and the positive sine theta are going to cancel. So I'm just going to remain with what? I'm going to remain with 1 plus 1. So on top I have 2 divided by, okay, what do I have down there? So here I can simply expand, okay? But if you want, you can use the difference of 2 squares, because this is just the difference of 2 squares, okay? So here I'm going to get 1 minus sine squared theta. But if you don't know how this has come about, let's show it now. So this guy here, we'll expand it from here. So it will be 1 multiplied by 1, it give me 1. 1 multiplied by minus sine theta, I get minus sine theta. And then positive sine theta multiplied by 1, I get plus sine theta. And then positive sine theta multiplied by minus sine theta, I'll get minus sine theta and then squared. So now sine theta squared is the same as, okay, to be 1, this here will cancel out, so I just have 1 minus sine squared theta. Okay, so this here, sine theta squared with a 2 outside like that. It's the same as I just put the square on the sign and then I leave out the angle. So this expression and this here are completely the same. So this is where this is coming from. Okay, but if you know what the difference of two squares is, you won't waste time trying to expand this. I'm just going to say, okay, this is the difference of 2 squared. So how do I get the answer there? I just say 1 multiplied by 1, I get 1. And then this multiplied by this, I get this. Okay, only if it's a difference of 2 squares, meaning that the expressions that you have are the same, but the only difference is the sign that you have in between. You can see here those positive, here those negative, but the rest is the same, right? Okay, so this, the trick for multiplying this multiplied by that, and then this multiplied by that, only works the difference of 2 squares. All right, so that's what we have in the denominator there, and then I'm going to say this should be equal to the right-hand side. Okay, so now what is 1 minus sine squared theta? Remember the identity that we have here. 1 minus sine squared theta here is what? Cos squared theta. Okay, so I'm just going to replace whatever is there with cos squared theta is equals to what? RHS, or the right-hand side. Okay, and then from here, I'm going to say, okay, let me say 2 multiplied by 1 over cos squared theta, and this should be equals to the right-hand side. So now from our basic identities, remember we said, let me write it here. We said sec theta is equals to 1 over cos theta, right? So if I square the sec here, it means I also have to square the cos like that. So 1 over cos squared theta is the same as sec squared theta um, there. Okay, so this part here just becomes the cos, the sec, sorry, squared theta like that. And this should be equals to right hand side. Okay, and this will just be 2 sec squared theta is equals to right hand side. And you can see that this here is exactly what we had on the right hand side. Okay, so we have proved our identity. You even say hence proved. So any questions there? Any questions, guys? Okay, I hope you've understood. We move to the next identity. So this one here says prove the identity sec theta plus cosec theta over 1 plus tan theta is equals to cosec theta. Okay, so I said you always prove the part that looks complicated. Okay, so now here we're just going to express each of these in terms of the basic trigonometric ratios. Okay, so we said what was the sec squared theta? So sec sec theta is just 1 over cos theta. Okay. Cos sec theta is just 1 over sine theta. Okay, and then the tan, we said the tan was sine theta over cos theta like that. Okay, so that is what we have there. So I'm going to replace each of these with these guys. So it will just be, okay, I'll write it in this form now to be 1 over cos squared theta plus 1 over sine theta. Okay, 1 over cos theta, 1 over sine theta for these two. And then instead of writing divided by like that, I'll just write divided by, and then I have 1 plus sine sine theta over cos theta like this. And then this should be equals to the right hand side, which is just this guy. Okay, so let's try to see if we can simplify this into looking something like this. So what are we going to do? We're going to say, okay, here, what is the common denominator? Common denominator there is sine theta cos theta. Okay, this into this, I just get the sine theta multiplied by 1, I get sine theta, plus this into this, I get the cos theta multiplied by the 1, I get cos theta, divided by, here I say the common denominator there will just be cos theta, because here I can say 1 over 1. 1 into this, cos square theta, cos theta multiplied by the 1, I get cos theta, plus the cos theta into cos theta, that is 1, multiplied by sine theta, I just get sine theta. Okay, this should be equals to the right-hand side. So meaning that here I can change this sign and then I'll change the positions of whatever is here. So this will go up, this one will come down. So it will be sine theta plus cos theta divided by sine theta cos theta multiplied by, okay, what I have here is that this guy goes on top. So it's cos theta. And then this guy on top, I'm going to write it as sine theta plus cos theta, because I know that addition is commutative. Okay, so meaning that cos theta plus sine theta is the same as sine theta plus cos theta. Okay, so now from here, what do we see? We see that this guy is going to cancel out. Okay, this guy is going to cancel out with that guy. So what I remain is this cos again is going to cancel out with the cos. So what I remain here is just the 1, even here just the 1, even there just the 1. So what I have is 1 multiplied by 1, I get 1 over sine theta multiplied by 1, I get sine theta. And this should be equal to the right-hand side. Okay, but what do we have on the right-hand side? Okay, we just have cosec theta, which is just 1 over sine here. So this is cosec theta, which is equals to the right-hand side. So hence proved. Okay, so any questions there? Okay, so you've seen, guys, that the identities, they just look complex and complicated. But if you just know the basics, you'll be able to prove them nicely like that. Okay, so we've proved that identity. If there are no questions, I'll move to the next one. Okay, I'll move to the next one. So the next one is which one now? Okay, so the next one is this one here. Looks even more complicated, but you're going to see, we're just going to follow the simple steps, just using the basic trig identities that we know, then we'll be done. Okay, so here they're saying prove the identity. They've given us this thing is equals to that. So which one looks more complicated? Okay, the one that looks big is this one. So we're going to try to make this one to look like this. Okay, so let's try. So what we are going to do there, we're just going to say, okay, common denominator there is what? So it will be this multiplied by this. Okay, so it will be cos theta plus sine theta in brackets, and then cos theta minus sine theta. Okay, so you can see that this is just a difference of two squares here, because they are the same. The only difference is the sign that they have in between. Okay, so this should be equals to the right-hand side. So now let's try to manipulate this. So cos theta plus sine theta into this will cancel out. I'll just remain with this. So it will be this multiplied by the sine theta. So it will be sine theta and then cos theta minus sine theta like this. Okay, and then that would be plus cos theta minus sine theta. Okay, it's going to cancel out this. So I'm just going to remain with this multiplied by what I have on top. So what I have on top is 1 minus cos theta. And then here I'm having cos theta plus sine theta. Okay, that's what I'm having. All right, so the next thing there is just to try to expand. Whatever is on top there, you expand. And then even what you have in the denominator there, you also what? Expand. So I'm going to say on top, I have this multiplied by this. It's giving me sine theta cos theta. This. Oh, okay. So this multiplied by this, I get minus sine squared x, sine squared theta Okay, so I've expanded this. I can now go on and expand this guy here. So this will be 1 multiplied by cos theta, I get cos theta. 1 multiplied by sine theta, I get plus sine theta. Okay, and then uh, minus cos theta multiplied by cos theta, I get minus cos squared theta. Minus cos theta multiplied by the sine theta, I get minus, okay, get minus sine theta, then cos theta. Okay, so that is what I get there. Okay, so I'm going to write it here, so it will be plus cos theta plus sine theta, okay, minus cos squared theta minus sine theta cos theta. Okay, that's what I get when I expand there. And then all this is going to be under what? Okay, I'm just going to multiply here. This multiplied by this, I get cos squared theta. Then this multiplied by this, I get minus sine squared theta. Okay, so I'm able to multiply the denominator like that because this is a difference of two squares. If it's not a difference of two squares, then I'm supposed to expand everything like I did with this one and this one. All right, so that is what I get. And then on top, you can see some things are going to cancel. So you can see that this guy, this one here, is the same as this guy. So they will cancel out. So what I remain with on top, I'm going to write it as sine theta plus cos theta. Okay, and then minus. Okay, I'll factorize the negative from this guy and also factorize the negative from this guy. So meaning that someone has a question? The one with the mic on. Oh, okay. Yeah, so I was saying I factorize a negative from this and this one here. So that is the negative there. So meaning in brackets, I'm just going to have sine squared theta plus cos squared theta like that. Okay, so it means I'm done with the numerator. And then I go to the denominator. This one here, I want it to look like this. So this one has all signs there. So I'm going to replace this cos squared theta with something that has a sign. So remember, we said sine squared theta plus cos squared theta is equals to 1. So meaning that cos squared theta is equals to 1. I take this into the other side, minus sine squared theta. So I'm going to replace this guy with this. So it will be 1 minus sine squared theta minus sine squared theta. And this one should be equals to the right-hand side. Okay, so that is what we have there. From there, what are we going to do? We're just going to see that we've actually proved the identity here. Okay, we've actually proved the identity because what I have here, okay, I can just write it in the way that they want because addition is commutative. So I'll start with the cos. So it will be cos theta plus sine theta. Okay, and then this one will be minus. What is this thing in brackets? See, the identity is there. This is just 1. So that would be minus 1 divided by 1 minus. These things are the same. So I combine them, I get 2 of them. Okay, and this is exactly what is on the right-hand side. Done. Okay, so any questions there on proving the identities? Okay, so I've literally taught you the basics. Okay, so if you want to be good in proving the identities or you don't want to have any challenges in proving the identities, first master the basic trig identities that I gave you on the in the introduction. Okay, and then once you do that, you can actually prove any identity. Okay. All right, so we're done with the identities. We go on now to solving some trig equations. Okay, so this one here will be our first trig equations. Okay, so most of the trig equations that I was finding in your past papers are the ones that are dealt with like you are having a quadratic equation. Okay, so remember I said if I have cos theta squared, this is the same as cos squared theta, right? Okay, so remember that. We're going to use that. Okay, so now when solving trigonometric equations, it's not hard at all. Okay, it's just the same as solving regular equations. But now the only difference is that we have some trig ratios that have been fused into that equation. Okay, all right, so when solving trig equations and then you have a trig ratio that is squared, then it means you have a quadratic trig ratio. I mean, you have a quadratic trig equation. So if you have a quadratic trig equation, it means, first of all, you're going to have, because for any trig equation that you have, anyway, to depend on the period that you have, but for most of them, for any trig equation that you're going to have, you're always going to find two angles or more. Okay, so for any trig equation that you have, you can never find an answer like just one answer. No, you always find two or more. Okay, and then if you have a quadratic trig equation, it means your answer will be four. You'll be finding four answers. So for example, like this one here, they're saying solve the trigonometric equation. Okay, for the theta between 0 degrees and 360. So if I write this 6 cos squared theta plus cos theta, I'll bring the 1 to the other side so that it becomes minus 1 is equals to 0. Okay, but this here looks like something we know. It looks like a quadratic. Okay, the only difference is that the thing that we were taking as x in the quadratic has now been replaced by a trig ratio. So to solve this easily, I'm just going to say let x be equals to cos theta. Okay, and remember I said this part here, the cos squared theta is the same as cos theta squared. So I'll write it as 6 cos theta squared plus cos theta minus 1 is equals to 0. So now, wherever there's cos theta, I'm going to put x. Okay, because I've said let x be equals to this. So it will be 6x, where there was this guy, and then squared, plus this is x again, minus 1 is equals to 0. So can you fail to solve a quadratic equation? The answer is no. We all know how to solve quadratic equations, right? So let's forget about the trigonometry. First of all, let's just solve the trigonometric equation that we have. So we're going to say, okay, my factor, my sum, and then uh, my product, my factor, and my sum there. Okay, so what is the product there? The product is 6 multiplied by minus 1, which is minus 6. The sum is a positive 1. Okay, so meaning what are the factors? The factors will just be positive 3 and minus 2. When I multiply this, I get minus 6. When I add them, I get a positive 1. So I'm going to represent this guy here, the plus x, in terms of the factors. Okay, so it will just be 6x squared plus 3x minus 2x minus 1 is equals to 0. You've seen that I haven't changed anything in the equation. I've just represented this guy in form of this. Okay, so now I'm going to group. This will go with that, then that will go with that. So what is common here in the first bracket? So what is common in the first bracket is 3x. So I'm going to say 3x. Okay, so if I factorize a 3x from here, I get 2x. Then there, just get plus 1. Here, I'll factorize a minus 1. So minus 1 is common. I remain with 2x plus 1 is equals to 0. So meaning here will just be 2x plus 1 and then 3x minus 1. This is equals to 0. Okay, so I can equate each of these to get the value of x. Okay, I can equate each of these to 0 to get the value of x, right? Okay, so what we have now is this scenario. So it will be 2x plus 1 is equals to 0. Then on the other side, 3x minus 1 is equals to 0. So here I'll just get x is equals to minus 1 divided by 2. On the other side, I'll get x is equals to 1 over what? 3. Okay, so those are the values of x. Okay, so we found our value of x. But remember, our goal is not to find the value of x, but to find the value of theta. Okay, because we are solving this trig ratio. So now we recall that my x was cos theta. Okay, so meaning here where there's x, I put cos theta. is equals to minus 1 over 2. And then even there, where there's x, I put cos theta is equals to 1 over 2. I mean 1 over 3. Okay, and then from there we can find the angles now. Okay, so we might use the calculator there. So for this one, we are going to say, I'm going to say theta is equals to the cos inverse of what? Okay, so I'm going to ignore the negative sign and I'm just going to say half. So theta will just be equals to, what is the cos inverse of half? Okay, so there we might need a calculator. Or if you know the special angle, you can simply write it down. Okay, so the cos inverse of the cos inverse of 1 over 2 is 60. Okay, so this is 60 degrees. Okay, but this 60 degrees, it will be an angle in the first quadrant. But remember here, our cos theta is saying it's a negative. So we are interested in the quadrants where the cos is negative. Okay, so let me write the quadrant somewhere here. So remember we have 4 quadrants, right? So there's the first quadrant here. All students take Coke. So in the first quadrant, everything is positive. Here, only the sign is positive, the cos is negative, the tan is negative. Here, only the tan is negative, meaning the other two, the tan is positive here, and then the other two are negative. And then here, only uh, the cos is, the cos is positive, and then the other two are negative. Okay, so now here it is from 0 to 90 degrees. Then here it is 180. Here it is 270, and then there it is 360, like that. So the angle that I found is 60. So meaning this angle is here. It's in the first quadrant. Okay. But here you can see that this guy here has a negative. So to find the angles that satisfy this equation here, I'm just going to find the reference angles, okay, or the angles in the negative quadrants for the cos. So the cos is negative here and here. Okay, in the second and third quadrant. So how do you find the angle in the second quadrant? So the angle in the second quadrant, you simply find it by saying angle in the second quadrant will just be equals to 180 minus the angle in the first quadrant. Okay, so I'll just write theta in the first quadrant. So here to be theta in the second quadrant. Okay, and then theta in the third quadrant, you find it by saying 180 plus the theta in the first quadrant. Okay, I can also do for here. So theta in the fourth quadrant, you find it by saying 160 minus the theta in the first quadrant. So those are the formulas. So from here, I'm going to get 2 values for the angle, and I'm going to use these formulas here because the cos there is negative. So I'm going to say the first angle, which is in the second quadrant, will just be 180 minus the one in the first quadrant. So this gives me a 120 degrees. Okay, the other one will be 180 plus 60, which will just give me a 210. Okay, to give me, is it 240? Yeah, 240, not 210, sorry. So that one will give me 240 degrees. So these here are the angles that are coming from this guy here. Okay, remember I said each trig equation has to give you at least 2 answers. So this one has given me 2. Again, I also go to this one, I get 2 answers. Okay, so from this, I'm going to say theta is equals to the cos inverse of 1 over 2. So here it's positive, okay? So meaning that the first angle that I'm going to find here will be there, and then where else is it positive? It will be there. Okay, so to find the angle here, I'll just say 360 minus the angle that I'll find here. So you go on your calculator, you punch cos inverse of 1 over 3. Okay, you're going to get approximately 70.5 degrees. So meaning that the angle in the fourth quadrant will just be 360 minus 70.5. So that will give me a 289.5 degrees. Okay, so these here are the 2 angles for this guy. So meaning that my answers to this trigonometric equation will just be that theta is equals to, you arrange them in order from the smallest. So the smallest is this. So that will be 70.5 degrees. And then I go to the 120 degrees. Then I go to the 240 degrees. And then I go to the last one there, 289.5 degrees. So you see that this is the angle in the first quadrant, second quadrant, third quadrant, fourth quadrant. So whenever you have a trig equation that has a squared, you are expected to find four answers. Okay, an answer in each of the four quadrants like that. So this is the answer here. So this is what you write as your final answer. Okay, so any questions there? Okay, so we move to the next. Okay, so this here is just a similar thing um, that we are from doing, but here now we're just having the sign. Okay, so I'll do the same thing. I'll say 2 sine theta squared, because it's the same as this, plus sine theta minus 6 is equals to 0. Then I'll say let x be equals to sine theta. Okay, so meaning that I have 2x squared plus x minus 6 is equals to 0, product, factor, and then the sum. Okay, so what is the product there? What is the factor? What is the sum? The product is minus 12. Okay, so meaning the sum is 1 positive. So what are the factors? The factors there will just be positive 4 and minus 3. If I multiply, I get this. If I add, I get this. So it will be 2x squared plus 4x minus 3x minus 6 is equals to 0. From there, I'll just group this guy with this, that guy with that. What is common here? 2x. Okay, what I remain with there, I remain with x plus 2. Then what is common here? Minus 3. I remain with x plus 2 is equals to 0. So I have x plus 2 and then 2x minus 3 is equals to 0. So if I equate this to 0, I get x is equals to minus 2. Or if I equate this to 0, I get x is equals to, uh, this just be 3 over 2. So 3 over 2 is 1.5. Okay, so now we can go back to our equation to try to solve for the theta. Okay, so I replace this x with the sign. So to be sine theta is equals to minus 2, or sine theta is equals to 1.5. So now look at the numbers that we have on the right there. They are bigger than 1, right? Or they are bigger than minus 1. Or they are smaller than minus 1. So the sine theta is only valid, okay, between 1 and minus 1. No wonder when you sketch its graph, to just be 1 minus 1, to just be oscillating between these 2 points like this. So the sine function never crosses the 1 to go to the 1.5 or to go to the 2. It never does that. Okay, so meaning here, there are actually no solutions. So the answer, just say no solutions. If you want, you can try to punch this on your calculator. So say theta and then sine inverse of minus 2. Oh, of positive 2. We ignore the sign. Or also do theta is equals to sine inverse of 1.5. So both of these are going to give you math error on your calculator, or they are going to say undefined. Okay, so this is math error. Why is it giving you math error? Because the sign is only defined from minus 1 to positive 1. And it's the same story with the cos. Okay, so immediately you just find these x values to be something that is greater than 1, okay, or something that is less than minus 1. Just know that there are no solutions there. So to this equation here, there are no solutions that satisfy it. All right, any questions there? Okay, no question. So we move. The other question here says define the following terms. Okay, so one, they're saying an even function. Okay, so we're going to say a function f of x is even, okay, if f of minus x is the same as f of x. Okay, that's an even function. I can even define the odd function. Okay, so if something is odd, then what does that mean? If something is odd, then minus of f of x is equals to f of minus x. Okay, but in terms of the graph, what does an even function mean? Okay, so in terms of the graph, an even function simply means the graph is symmetric about the y-axis. Okay, it's symmetric about the y-axis. So what does that mean? It means that the y-axis acts like the mirror. Someone has a question? Heard someone speaking. Hello? Okay. All right. So I was saying the meaning now, the graphical meaning of an even function is that it is symmetric about the y-axis. Okay. So what does it mean to be symmetric about the y-axis? Simply means the y-axis acts like a mirror. So a good example of an even function is the cos theta. So the graph of the cos theta will look something like this. Okay, it will start at 1 here, and then it will go down like this, and then it will end at 1 again there. So this is 360, this is 0. Okay, somewhere there should be the midpoint of this. So this is like 180. Okay, somewhere there, the midpoint. So this is minus 1. Okay, and then there should be 270, and then there should be 90 like this. Okay, so this is the graph of the cos. Okay, so we are saying if the function is even, then it's symmetric about the y. So the characteristics of the cos graph is that even um on the left hand side here, even on the right anyway, it will continue to make such an arrangement. So it will go something like this. Just like that. Okay, and then you have this axis. So you see that this guy here, the y-axis, is acting like a mirror because whatever I get if I'm moving like that is what I get when I'm moving to the left like that. So this guy is acting like a mirror. Whatever I can see here is what I can see there. Okay, that's what it means to be even. Okay, all right. And then if it is odd, a good example is the sine function. So if you draw the sine function, okay, to start at 1 minus 1, to start at 0, goes to the 1, turns back, and then ends at 360. So this is 360, where it is peak there, it's 90. Here, that is 180, and then down there, that is 270. That is minus 1. So you can see that this guy here is symmetric about the the origin. Okay, it's symmetric about the origin. Not necessarily the x-axis, no, but it's symmetric about the origin. Because this is the origin here, right? So if I continue the sine graph, it will go something like this. Then it will come up like this, come up like this. Yeah. So this point here, the origin, is acting like the mirror for the sine graph. Okay. Because if I'm at the origin and then I start to move like this, okay, it's the same thing that I'll experience when I'm moving backwards like that. So the sine graph, it's symmetric about the origin. So if something is symmetric about the origin, then we're going to say it is an odd function. Okay, so that's what it means. And then the other question there was to define what a periodic function is. So let's define a periodic function now. Okay, so I'm going to say a function f of x is called periodic if there exists a positive number t such that f of x plus t is equals to f of x. Okay, so this function f of x is a periodic function or is called a periodic function if there exists, okay, if there exists a number t such that, okay, f of x plus t is equals to f of x. Okay, so if there exists such a number for that property to hold, then we're going to say the f of x is a periodic function. Okay, so the least positive value t is what we call as the period, this t here. Right, so now to understand this better, let's look at this example here. So this example here, they're saying show that f of x is equals to sine x is a periodic function with period 360. Okay, so here our t is 360 degrees. So to show that this guy is a periodic function, I just have to show that f of x plus the period t is equals to f of x. Okay, so this will be f of x plus 360 degrees should be equals to f of x. So now what was our f of x? Our f of x was just sine x, right? So meaning f of x plus 360 to be sine x plus 360 degrees. So this should just be equals to sine x. Okay, so let's just expand this using the double angle formula. Okay, so this will just be sine x cos 360 plus plus sine 360 and then cos x is equals to sine x. So now, what is sine 360? Sine 360 is 0. So this guy here becomes 0. Okay, so I just remain with this. And then what is cos 360? This is 1. So it will be sine x multiplied by 1. So I get sine x is equals to sine x. Okay, so you can see here that sine x plus 360 is simply equals to what? Sine x, because we're able to reduce this to sine x, which is equals to the right-hand side there. So therefore, we've shown that f of x is a periodic function with period what? 360 degrees. Okay, so any questions there? Okay, let's look at the last question, which is on graphing. So the graphing part says sketch the graph of f of theta is equals to 2 is equals to cos 2 theta uh, with a theta that is between 0 and 360. Okay, so before we sketch any trig ratio, we have to take note of the amplitude, the period, and then the phase shift. Okay, so I'm going to say in general, okay, when we have a trig function in general, it will be represented like this. It will be a cos, okay, a cos, let's say 2x plus b, okay. Oh, why did I write 2 there? Okay, so a cos bx plus c plus d. Okay, here I can write plus or minus, but I'll just choose for the plus now. Okay, so meaning that if I have such an equation, I always have to get the amplitude. So the amplitude, okay, to just be how far, or it will just be the height of the graph in short, how far it can go down and how high it can go above. So the amplitude is always the modulus of the part, the coefficient of the trig ratio there. So A. So it will be the modulus of A. That is the amplitude. And then the period, okay, the period will be equals to, if you're using degrees, it will be 360 divided by the coefficient of x. So in this case, the coefficient of x there is what? B. So I'm not to divide by b if I'm using the degrees anyway. But there are some other times when you're using the radians, so you're going to say 2 pi over b. Okay, so uh, that is how we get the period there. So just a minute. Okay, so I was saying this is how you can find the period. And then now the other thing that you need to find when you are graphing trig graphs is the phase shift. Okay, so the phase shift shows you um, if the graph has moved to the right or it has moved to the left. So how do you find that shift? You equate whatever is in the brackets here to 0, then you solve for x. So in this case, it will be like bx plus c is equals to 0. Okay, and then I solve for x, it will just be x is equals to minus c over b. So meaning uh, it has moved c over b units to the left because this is a negative here. Okay, the other thing that you need is a vertical shift if it exists. Okay, so the vertical shift, it's simply the d that is there. Okay, so if it is positive, it means the vertical shift happened going up. If it is negative, then it happened going down. So these are the things that you need, and then just plot them to have your graph. Okay, so now the important thing that you have to understand here is the period here. So the period tells you in how many degrees or in how many radians you're going to have a full cycle. Okay, so if let's say your period is 360, then it means from 0 to 360 you should have a full cycle for that trigonometric ratio. Okay, if your period is 180, then from 0 to 180 you must have a full cycle of that trig ratio that you have. If your period is 90, then from 0 to 90 you must have a full cycle. Okay, so meaning that if the range for the degrees that you have is maybe 0 to 360 in this case, and then you find your your period to be 180, it means that you're going to have two full cycles happening from 0 to 180. The first one from 0 to 180, then the other one from 180 to 360. Okay, so that is the case that we're going to see here. Okay, so now if I get this guy that we have here, f of theta is equals to 2, I mean cos 2 theta. Okay, amplitude, it will be what? Okay, so what is the coefficient of this cos? There's just nothing here, so it is 1. So it will be the modulus of 1, which is just 1. The period will be equals to 360 degrees divided by the b. B is the coefficient of x or whatever variable is there. So in case this here is the theta. So what is in front of the theta is 2. So gives me 180. So meaning that in 180, I should have a full cycle for the what? For the cos function. Then the phase shift, there's no phase shift here because if I equate 2 theta to 0, I'm just going to get theta is equals to 0. So it didn't move to the right, didn't move to the left. It's just the way it is. The vertical shift, there's no vertical shift because there's nothing like plus something here. So the vertical shift there is 0. Okay, so now to sketch this one, we just have to go back to the general graph of the course. So the course is like this. Okay, so the course is 1 to minus 1. And then I have 90, I have 180, I have 270, and then I have 360. So it starts at 1, passes through the 90, and then tends at uh, tends at 180. Okay, so it comes like that. Then tends at 180, goes back like that, passes to the 270 and then stops at 360 like that. So this here is the same level 1. And then there, the lowest part is minus 1. Okay, so this is the general structure of the cos theta. But now here, the only difference is that here the period is 180. So from 0 here to 180, I must have a full circle like this. And then from 180 to 360, I should also have another full circle. So it's going to be appearing something like this. So this will be my minus 1, and then 1. Okay, so this is 90, and then 180, and then 270, and then 360, right? So the period tells us that it's 180. So meaning from 0 to 180, there should be a full cycle. Okay, there should be a full cycle. So meaning it to start from here, 10 something like that. Okay, so it will start from 1, then at 90 to 10, then to go like this. So this is my first cycle. You can see it's a full cycle for the course. Then from 180 here, I start another one. Okay, so that is the second one. So the first one ends there, then the second one is this, it ends there. So you can see that because it was 2 theta here, we have 2 cycles from 0 to 360. So this here is the graph of our f theta of cos 2 theta. All right, so any questions there, guys? Okay, so if there are no questions, this is what I prepared for today. We end here, but remember to revise using the website. So the videos are already there for the tutorial sheet on trigonometry. So Tutor Marius solved all the questions for the trigonometric tutorial sheet. So make sure you check out the video, you learn from there. You can also check out the video on polynomials, it's there. The video on binomials is there. So you can literally learn anytime. You don't always have to wait for us to host a live class. You can learn anytime. Okay, so we end here for today. By tomorrow, I think Tutamaras will be there. We'll take up the class. So I don't know what you revise tomorrow, but it will be based on the test that you are having.